morning. Over the next 20 minutes I'm just going to do a whistle-stop introduction to the Thor Helical Remedial Masonry Repair Systems. My name is Paul Shepherd. I'm the Technical Support Manager for Thor Helical Remedial, being the structural arm of the Wickham Group. Many years ago I came out of mainline in civils, got sick of setting out roads, and went into the specialist contracting industry in the concrete repair market. I left the concrete repair market and went into the helical industry about 9 years ago now, and I've been with Thor Helical for about 5. I'm just going to basically introduce the actual product now. This is the product that I'm talking about. Many of you may have seen it, many of you haven't seen it. It's been around on the market for somewhere in the region of 23 years now, and I still maintain that our biggest competition is ignorance of the product. The basic wire is a stainless steel product. It's an austenitic stainless steel. Probably 90% of what we do is in grade 304, quite a high grade stainless steel. We also do a 316 marine grade stainless when necessary. During its formation process, we actually roll the wire out into the shape that it is, i.e. the helical fins. The fins themselves become harder than the central core. This is called work hardening, so to say there is actual change of material property as the material is rolled out, cold rolled from the central core, from the round wire, into the fins. Quite a strong bar, 6mm bar, which is predominantly used for crack stitching works, things like that. We can hang nearly a ton on that before it would snap. What it means in practice is that we never actually snap one of these in the wall. We always ensure that the scheme is designed that the masonry itself would fail before the reinforcement system. I mentioned this high fin profile. It's this high fin profile on the actual surround of the bar that allows us to lock it into the structure. Very, very high cross-sectional area, very, very high surface area to the cross-section area, and it's ideal for actually physically locking it into the structure, and it has to become part of the structure to work. The manufacturing processes we use, when we are talking about the smaller fixings, when we drive them into substrates, the straighter the better. So they say the processes that we use have a very, very straight central core. The other thing that we've got now, we've got a very, very good pitch accuracy when we actually spin the wire. This is very important when you're driving something into a substrate. If there's any variation in the pitch, as you drive the fixing in, you actually start to ream the hole out. So you start to lose connectivity the deeper you drive it. So we need a very, very accurate pitch. It's normally installed into masonry to resist the tensile forces that would crack masonry. Masonry is fairly awful in tension, very good in compression, but it's pretty awful in tension. And most of the cracks you will see in masonry are tensile cracks. The important thing when we deal with masonry structures is masonry moves, and masonry will always continue to move. So the inherent system itself has to remain flexible. We need to maintain flexibility. That natural building movement has to be accommodated within the system. We're currently manufacturing in 4 sizes. 5 and 6mm diameters are used for crack stitching, bed joint reinforcement, and the 7 and 9mm diameters are used for pinning applications generally. We've got to lock this product into the substrate with some particular material. The product that we normally recommend is a product called Thor 60 grout. It's been specifically designed to bond this type of reinforcement into masonry structures. Pardon the phrase, it does exactly what it says on the tin. It's a pre-batched, high-strength cementitious grout. It bonds superbly to clean masonry. As far as our installers are concerned, that clean bit is probably the worst, the thing they've got to take care of on site. We haven't produced anything that bonds to dust yet. When we have done, but I won't be here because we're all going to be tied to the Bahamas. But to clean masonry, this bonds extremely well. Non-shrink, critical if you're looking at remedial works. If you're cutting slots or drilling holes into buildings, whatever you put into there has to be non-shrink. If it doesn't stay the same volume and shrinks like a lot of building materials do, it has to debond. So it's critical that it's a non-shrink material. It's thixotropic. What that means is it stays where it's put. We can actually quite happily gun this material in the slots directly overhead if you want to leave your elbow or your armpit. So yeah, it's a very, very easy material to use. Rapid early strength gain as far as cementitious products are concerned. So within a day or so, we're up to sort of structural strength. The actual sections we use, we can maintain this inherent flexibility of the product even when we lock it in with a very, very hard cementitious grout, high-strength cementitious grout, which is critical when we're looking at historic projects, particularly if you've got the bodies like English Heritage, historic Scotland, or people like this, who are very adverse to using cementitious products in their building. The most used application of this product is crack stitching. I think most of us are familiar with the sort of crack stitching. The definition that we have of crack stitching is to reinstate the structural integrity of the building as it was built. Because of that definition, crack stitching is probably one of the most misspecified applications of our product, because we still get surveyors and engineers who will see a crack in a building and crack stitch it. It's important before you crack stitch something that you actually ensure that the cause of the crack in the first place is addressed. If you don't address it, and you just crack stitch the crack, and the underlying cause continues, the building is going to crack again. Probably not on the line that you've just put a lot of bars across, but it's going to go to the next weakest point. But that said, so you've sorted out the drains, trees, whatever is causing the underlying movement, it's still important that we actually address the crack. Normally we use a minimum 1 metre bar, has to be anchored either side of the track, minimum of 500 millimetres. Longer in unsound substrates. Sound masonry, 500 either side is perfectly adequate. But in unsound masonry, if you're looking at live mortars, things like that, you may have to go further. Normally sort of 450 vertical centres, 6 courses. On very severe cracks, you can close that down to about 300 mil vertical centres, but no closer. We've seen specifications for every bed joint. We'll quite happily sell you the bar and grout to do it, but realistically, you're probably doing more damage to the actual structure cutting that number of slots in it. That's crack stitching, very straightforward. Going on from there, we can use the helical products to actually enhance the strength of masonry. What we're doing here is actually enabling masonry to do something which it wasn't necessarily designed to do. And it normally involves the formation of a masonry beam. So the beam action itself is probably the easiest demonstration in a single application. But it works equally well on the ground, whether you form the ground beam or whatever.